So what I'd like you to do, I want you to complete this table, okay? So I'll start you off with one of them. So 10 is 10 to the power of what? 1. So we're writing these all with base 10. And then in our calculator, I want you to type in log 10. So on your calculator, log 10, and it gives us 1. Okay, so I want you to complete this table. Okay, so what would be this guy here? 10 squared, then we have 10 cubed, right? It's a number of zeros. 10 to the 4, 10 to the 5, and 10 to the 6. What was log of 100? So you type in log 100, it gives you 2. What's log 1,000? 3. Log 4, 5, 6. So one thing you should notice is logs are completely related to an exponential function. In fact, to get what it equals, we want to ask, if this is my inside, 10 to the power of what would give me 1,000? It's basically the reasoning. So we're going to practice changing from logs to exponential and back and forth today. Yep. Okay, so let's just look here. What would have to go here? Log 10 of what would equal 2? Guys, shouldn't be talking. There's a bunch of people back there. So it would be log 10 of 100. Because 10 squared gives you 100. The inside is equal to the base, and then whatever this equals here is the exponent. So 10 squared equals 100. So 10 to the power of 3 would give you, excuse me, 1,000. Because 10 cubed is 1,000. So here, log what would give you 4? 10,000. Because 10 to the power of 4 is 10,000. So how do we switch between logs and exponents? Well, let me show you. So given this guy, we want to write him as a power. So what would he become? Well, does anyone want to take a guess? You want to switch that to exponential form? What does that, when we look at that, what does that mean? Log 500 equals 2.698. How does that work? Well, looking back at what we just did. So what would be our base? 10 to the power of what? What would be the exponent? Would it be 500? No. 2.698 should equal 500. Okay, so when we're changing from logs to exponential form and vice versa, what this means, our base to the power of that, so this is our exponent over here. This is the exponent. This is what we call the base, and this is what we would call the answer. Yeah, it's a little weird. So logs is a way to solve for the exponent. Notice how equals the exponent. So we use logs when we want to solve for the exponent, and we can't use change of base, and we want an exact value answer, not a decimal usually. Okay, so that's what logs are used for. It's completely related to exponents. So 10 to the power of 2.6 equals the answer. So you're always going to go in that rotation. Okay, so here's the formulas. So the function log x, right, if there's no base written, we always assume it's 10, is equivalent to 10 to the power of y equals x. So inside's the answer, y would be the exponent. And if we have natural log, what's the base of a natural log? E. It's a little e. So my base would be e to the power of y would equal x. E to the power of y equals x. The inside of the log is the answer. This is the base, and this would be your exponent. Okay? So let's try converting back and forth. So what would this become? What's the base? 7 to the power of 4 equals x. Good. Try the next one on your own. Change it to exponential form. Is it? It's not that bad. It's not like yesterday's. It's good. So 10 to the power of what? 3 equals 1,000, and this last guy, it's kind of weird looking. What's my base? X is the base to the power of b to the d equals, yeah? It's x to the power of b to the power of d. Okay? Equals a. It's really ugly looking. X to the power of b to the power of d. Yeah. Yeah. So you could also look at it like this if you wanted to, if that makes sense. It's really ugly as it is. Yeah. Yeah. Okay, let's go the other direction now. So writing this as a log. So we would write log, what would be the base for? 4 of 64 equals 3. So base answer equals exponent. Easy. So a log, yeah, is inverse of an exponential, and it's used to solve for exponents. So we can change it to this form, and it'll equal our exponent. Okay, so this guy, what's my base? Log 2 of, answer would be 1/8 equals -3, our exponent. It's always like a subscript beside the log, and we write it whenever it's not a base of 10. So the common log is base 10. If it's not 10, we have to write that little number to tell whoever's looking at this, this is the base. Okay, this guy, what's my base? Nope. Base is attached with the exponent. 2x plus 4 is the base. Answer is a equals our exponent, -1. That one's just ugly. Okay. So when we're solving for an exponent, and we can't make the same base, so same base is what we used last unit. That's when we have to change to log form. Change to a log. So at this point, the only way you knew how to solve, if you couldn't change the base, was which method? What did we do? Graphed it and found the intersection. Okay? So in logs, we're going to learn if we can't make the change base, graphing is one way, logs is another way to solve for the answer. Okay, so it's like a third way for solving for our exponent. So here, I'm looking for my exponent. It's my unknown. So let's write this as a log. Log, oh, that's yellow. Can you read that? I kind of like it. It's a nice color, mustard yellow. Dijon mustard. Ooh, I like that. Okay, what's my base? 10. Do I have to write 10? No, you don't have to write. When the base is 10, you're using a log. You don't have to write base 10. Okay, so log base 10, we have to write, of what number? 32 equals y. Could we type that into our calculator now? Yes. Couldn't do this before. We had to go y1, y2. So now log 32 equals 1.51. Yeah. Well, it's nice having multiple methods. That's because that was exponential. We're going to spend a whole unit on logs. Yeah, lots of log stuff. Okay, so if it's base, so notice if it's base 10, we use the log. Okay, if it's base e, what type of log are we going to use? The natural log, L of n, right? Because L of n is base e. Okay, so how would we write this? I'm looking for my exponent, so we want to change it to log form because I can't make 25 base e. Just can't. So log, so you could use log base e, but then we whole another set of calculations. We're going to use natural log base e. Do we have to write it? No. Of 25 equals y. Y. E is an actual number, right? It's 2.71 something. It's like pi. It's a symbol that represents an irrational number. And it's used in logs, specifically the natural log. No, there isn't. There really should be. February 71st. That doesn't really work. So E, the reason what makes it so significant is when you get to calculus, and calculus is all about slopes, honestly. Everything about calculus is rate of change in slopes. Slopes, slopes, slopes. Remember you started learning about slopes in grade 10, okay? The slope of a line, how fast it's increasing or decreasing. What's very unique, so for example, if I had a quadratic graph and I graphed the equation of its slopes, no, it's negative slope here, zero slope here, positive slope here. And so it turns out to be like this would be the line of the slope. Okay? So what's so special about E, the graph of e to the x, when you graph the equation of its slope, it's the exact same line. And it's one of the only cases of that. When you always, and then, so that if you do the slope of that line, it's still the same line. So that's what makes it so special. Okay? So that's where the significance of E comes in. I love logs. Yeah. It's fun. I find it fun teaching. I'm gotta screw loose. It's a little loose. Okay. Let's tighten it. So natural log 25 is 3.2, yeah, let's go 3.22 is y. Okay, how can we verify our answers? How can I check my answer here? So into the original equation, e, so second natural log is e to the power of, and then I could just go answer. So whatever I just got should equal to what? Should equal to 25, and it does. Perfect. All right, and this first question, 10 to the power of that number, oh, exactly that number, should equal 30. If I used answer, it would give me 32. Yeah, so that's correct. Okay, so solve for the given variable. So we're going to play around with change of base a little bit. So let's change this from a log to exponent. Okay, exponential form. So what's my base? 5 to the power of y equals, my answer is root 125. So let's play around with change of base. Can we make 125 with a base of 5? 5 to the power of 3. Okay, how do we get it out of square root form? 2 over 3 or 3 over 2? Root, power over root. What's the power? 3, root is 2, 3 over 2. Okay, so what's y equal to? 3 over 2. Good. Okay, let's try this guy. So we're going to make this equal to y. So change it to exponential form. Or you can go 4 to the power of what equals 64. Yeah, so 4 to the power of what is 64? 3. Yeah, and so that would be equal y. And that would be the easiest way. It's asking yourself, 4 to the power of what? Equals 64, right? 4 to the power of y has to equal 64. Okay? 3 equals y. Yeah. Okay, this is a little harder. 2 to the power of what equals 1 over 32. So change of base might be a little easier in the when we can't just think of 2 to the power of what. So I'm going to change it to exponential. 2 to the power of, we'll call the what y, equals 1 over 32. So 2 to the power of what is 32? 5, and how do we move it up? What would happen to the 5? Negative, so y is equal to negative 5. Yeah. So really the focus this lesson is practicing changing from logs to exponents and exponents to logs. That's what we're really practicing. Okay, given the following two expressions, we want to find which one's greater. So let's start with this guy. Example 4. Yeah, 2 to the power of what equals 16? So grab your calculators. We can go, okay, is 2 cubed? No. Is 2 4? Yeah. So what is this equal to? 4 plus 2 to the power of what equals 2? 1. So that will equal to 5. Okay, so now 2 to the power of what is 64? Is it 6? Yeah. 6 divided by 2 to the power of what is 8? 3. Now I'm going to show you how to type these in your calculator in a second. And that equals 2. And we're going to learn about this rule later on. So because your calculator does only base 2 and base e, we have to do something called change of base to actually be able to put this in my calculator. So to figure this out in my calculator, you would type log 64 divided by log 2. And that will give you your 6. Let me show you. So log 64 divided by log 2, and that will give you your answer of 6. Okay, that's how you type that in your calculator. When it's not base 10, you divide by the log of the base. And then this guy, I would type in log 8 divided by log 2, and that gives me 3. So 6 divided by 3 gives me my answer of 2. Okay? If you can figure it out in your head, it's way faster. Right. It's really warm. Okay, so who's greater? Okay. So earthquakes and pH. Okay, here's the reality. Let me pause. Here's the reality about your diploma. Yes, you'll have some log questions that will just be calculating type logs and working with logs. But they really love questions with all this reading, right? Not really. It's applications. They really like applications. Unfortunately, they really test a lot of things. It's actually interesting. This stuff is really cool, I think. However, you need to be prepared for your diploma. Like, that was one of the biggest comments for January's diploma. So much reading, so much word problems. So take your time, read through it, and let's practice a bunch of these earthquakes. Because usually they're going to be an earthquake problem, a pH problem, so pH scales, log scales, or sorry, earthquake scales. Usually one of the two, I think, or decibels, noise, okay? So decibels, because the reason why is they all have a logarithmic scale. So what that means is a pH of 1 is 10 times more acidic than a pH of 2. A pH of 1 is 100 times bigger than a pH of 3. So it's related to an exponential function or log function. So that's why they're great. So like a decibel of like something, like decibels are very similar that way. So as far as intensity goes of a sound. Okay. Okay, so Richter scale is log. If you're in this course, the reason why you're in this course is you are post-secondary bound, right? And you're going to need a lot of the thinking skills and problem-solving skills for secondary. And math is going to help you with that, unfortunately. Okay, so dash 2 is for, right, some sort of post-secondary bound. And whether it be college, university. Yes, you can. You can. Yeah. That's why it has to be a hard enough course, right? Unfortunately. Okay, Richter scale is a logarithmic scale. A difference of 1 unit in magnitude corresponds to a factor of 10 difference in intensity. So 10 times difference for each one. This means that each whole number step represents a tenfold increase in intensity. We just talked about that. So here's the formula. The magnitude of an earthquake is given by this formula. So this is its magnitude, where I is the earthquake intensity and IO is a reference intensity amount. Okay, so how many times more intense? And that's where we're going to get our magnitude. So if we were to change this to an exponential form, what's the base here? What's the base if it's not written? 10. So 10 to the power of, our exponent would be m equals our answer of I over IO. If you were to change it. And so this formula here we get, if we want to compare one to another, if I want to actually compare the magnitude of one earthquake to the magnitude of another earthquake. Caitlin, can you put that on my desk? How they do that is they divide these two functions by each other. So if I have earthquake 1, and it has an intensity of, we'll call it I1. And I'm going to divide it by the other function, M2, intensity 2. So we're comparing two earthquakes. When you have the same base, what can we do with our exponents? Close? Subtract them. And so this is where we get M1 minus M2, so these are the magnitudes on the Richter scale, is equal to how many times more intense one is of the other. Okay, so that's where this formula comes from. It's derived from the logarithmic equation. Okay, so we just need to be able to work with this. Equations will be given to you on the diploma. You might have to change them maybe from a log equation to an exponential. Okay, so it says how many times more intense was the Mexico earthquake of 8.1 than the Turkey earthquake of 6.9. So how we do this is I want to compare who to who. Mexico to Turkey or Turkey to Mexico? Mexico to Turkey, because we're comparing how many more times intense was Mexico compared to Turkey. So the intensity of Mexico over the intensity of Turkey. So we want to compare how many more times intense is Mexico over Turkey. So it would be 10 to the power of Mexico minus Turkey as far as their scales. I should call them magnitude of M, magnitude of T. Okay, so what's the magnitude of Mexico? 8.1 minus 6.9. So 10 to the power of, what's 8.1 minus 6.9? 1.2? So to get how many more times intense, their difference of their Richter scale quantities, we just raise that to the power of 10 to find how many more intense. So if it was a 3 to a 1, the difference is 2. That's why it's 100 times more intense, 10 to the power of 2. Yeah. Yeah. Yep. So, no, top compared to bottom. Mexico to Turkey. Yeah. Okay, so what's 10 to the power of 1.2? What is it, Kristen? Oh, 15.85? So we could say it's 15.85 times more intense. It really is, right? And so, and unfortunately, how intense it is, it's partially measured by the seismographs, and it's also measured by destruction. It's sad, unfortunately.
Earthquakes are getting bigger and bigger.
Oh, end times. Jesus is coming. Okay. So, those are Richter scales. Very similar for pH. Very similar idea. So, in your homework, you're going to have to refer to this chart here. I printed out some if you want them, but I'll also put this up. So, our pH scale is very similar. It's 10 times more. So, like 0, what is that, acid or base? Acid, right? And this side would be base. And so if you compared battery acid to saliva, battery acid is 10 to the power of 6 times more intense. Tap water is usually like a little bit more acidic. It's like a 6.6. Yeah. Yeah. Mm-hmm. Yeah, so when we talk about, yeah, unfortunately, pH is everything. Okay, so when we're comparing, like if I wanted to compare the 2 to the 3, how many times more intense is it? 10, right? 2 is 10 more times acidic than 3. 3 is 10 times more basic than 2. Okay, so that's our scale, all that fun stuff there. Okay, so let's look at this. So our formula, has anyone ever seen this formula before in chemistry? Yes, yay! You've worked with logs before. Did you even know what it was? Just use it. Here's the formula. Yeah? Okay, so now you know what it is, and now you know why it works, because everything is about intensity, 10 times more, 100 times more, 1,000 times more. And that's how we get pH. And pH is related to the concentration of the hydrogen ions. Good old chemistry. Okay, so if I was to change this to an exponential function, we have a problem here. Okay, we have a problem. We can't change to exponential function if there's something in front of the log. The log has to be by itself. So how can I get rid of this negative in front? Divide both sides by -1. So this side can be whatever. That's our answer, or exponent. So dividing pH by -1 gives us negative pH. Equals log of our hydrogen concentration. Okay, so now we can change it to exponential because the log is by itself. What's the base if it's not written? 10 to the power of, what's my exponent? So I always like to do these arrows. Base, so it's like a circle we're making. 10 to the power of negative pH equals the hydrogen concentration. Have you seen that formula before? Yay! But you probably just had the formulas and didn't know how to convert them. They're really the same formula. They're the exact same thing. Crazy, mind blown, right? Okay. Okay, so if we want to talk about how many times more intense one is the other, we're going to divide again. So if I'm comparing the pH, the intensity of 1, so we'll call this one 1, over 2. So how many times more concentrated is it? How many times more acidic is it? This is concentration of hydrogen. It would be 10 to the power, so this would be the pH of 1 over the negative pH of 2. pH is so funny with a small p, big H, hey? So this is 1 and 2. If we have the same base, what are we going to do with our powers? Subtract them. Now we have a negative here, so it becomes pH 1 minus the negative pH 2. So what happens when you subtract a negative? You add. So it's going to be a positive. So I can have pH 2 minus the pH 1. So really the one that's more basic minus the one that's more acidic, and then to the power of. It's really just like the Richter scale. So if we have an example, I think there's an example on the next page. So we're going to use this formula. Copy. So on the next page, and we're done. Okay, so how many times more, if we're talking about intensity, we just really have to subtract their pHs and put it to the power of 10. So if here we're saying a patient is given a urine sample, which is found to have a pH of 5.7, what was the hydrogen iron? Oh, we need to do that part first. What is the hydrogen? Let's do a question first over here. I'm going to add one. So how many times more acidic is, let's go, vinegar to tap water, which is pH 6.6. Okay, so we're comparing vinegar to tap water. So what would it look like? 10 to the power of 6.6, the second minus the first. So 6.6 minus 3. So 10 to the power of 3.6, which gives you what? 10 to the power of 3.3 or 3.6? 3,981. Did you get the same thing? Times more acidic. That is, and it's related to like how much more concentration it is. It's more concentrated. Okay, one more question. It says a urine sample has a pH of 5.7. What was the hydrogen iron concentration? So our formula for hydrogen concentration, which they gave us, was the negative log of our pH, right? No, I did that wrong. pH equals negative log. Thank you. No one told me. Okay. No? Should we take our time? Sorry, am I rushing this? There's two types of questions you can ask. You can ask how many more times acidic or how many times more base. That's when we're using our exponents. Okay? If they're actually asking here, this one's what's the hydrogen concentration? I want to go back to our original question. So what do we know in this problem? The pH. The pH is 5.7. Okay. Is there a problem right now? Yeah, we're looking for the inside of a log, or the answer. So we need to change it to what form? Exponential. Okay, Leah, can I go straight to changing it to exponential? Can I change this straight to exponential, or do I have to do something first? Andrew? Is there anything wrong with this, or can we go straight to exponential? The negative in front, the log has to be by itself, so where do we put it? The other side. So negative 5.7, which I think you guys had the formula, log of your hydrogen equals negative pH. Is that what you had before, maybe? Okay. 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 So now we can change this to exponential. What's the base if you can't see it? 10 10 to the power of, why is your stuff put away? Okay, 10 to the power of, so this is our base, 10 to the power of negative 5.7 equals our answer, which is the hydrogen concentration. So what does that equal? So grab your calculators. It's because it's related to logs. Okay, so approximately 2.0 times 10 to the power of negative 6. And it's in moles per liter. Okay, so that's this lesson. So really practicing between converting from logs to exponents. Do that. Sorry, was this too much? Okay. Okay, you're going to need this table for your homework. I have handouts at the front if you need it, or you can refer to here. Okay?